Okay, so the two we're looking at, we're going to look at law of sines first. And again, this is still dealing with, this is not so much unit circle. We've got one more thing with the unit circle we'll do tomorrow. This is more going back to triangles for this part of it. And basically something like this. Okay, so if we're looking at these, we got angle A, angle B, and angle C. If you draw the sides on these, this would be, and this would, angles are all in capital letters. We talk about side lengths. This is going to be side A, which is lowercase a, side B, lowercase b, and side C would be a lowercase c. All right, so what you're going to do is that at this point, this is not necessarily a right triangle, but if we went back and drew a right angle here, where we drew like this side length that went from side C to angle C, kind of went through this one. Basically, we'd say that X is like an altitude. Because again, that's the height. That would be the height of the triangle, because that's like distance from the bottom to the top if we kind of look at it this way. And basically, what law of sines says is this: you got a couple options of things you can do with this one. Still kind of thinking about SOHCAHTOA sitting in the background for this one. That basically, if we talked about sine of A, that if we kind of covered this part of it now, sine of A would equal X over B. So if we got a right angle here, basically if we got this right angle drawn to either this side or this side, if we want to get it that way, if we cut this part of it off and kind of went through here, sine of A would equal X over B. And if you solve this thing for X, then X would equal sine of A times B, or we'll say B times sine of A. And again, well, you could kind of think about that kind of step in between there, that if we've got sine of A equals X over B, if we're trying to get basically do cross products here, so X would equal B times sine of A. So if you're kind of wondering where we jump from here to here, that if we're trying to get X by itself, we can do cross products. So it gets X by itself because it's 1 times X, and that means X is going to be equal B times sine of A. Okay, you could do the same thing over here on the other side. If we looked at this kind of part of the triangle now, you could say that sine of B would equal X over A. Or again, you could say that X would equal A times sine of B. Okay, so if we're trying to figure out what this height is, if we're trying to figure out what X is, we draw the altitude through this thing and draw it at a right angle. Basically, we've got that X is equal to this and X is equal to this, right? So X could be both of these two things. So if we kind of take a look at these two pieces, then if this is X and this is X, that means that this would have to equal that. So that B sine A would equal A sine B. Because again, this is X and this is X. Those two things have to be the same. So we can kind of set this equation here. And here's where we kind of go one more thing for this one, to kind of do some parts on this one. If we're trying to get the sine values by itself, we can divide this side by B. So that would cancel out. So we've got sine of A would equal A sine B over B. And then over here, if we want to get it so we've just got the sine values on top, we can divide this by A, so this would cancel. We basically would divide that part by A. Okay, so what it says is that basically if you can take the sine of A and divide it by A, that should equal the sine of B divided by B. And they say, well, just for a good measure, then we could do the same thing with C. So then we'll throw in one more thing and say sine of C over C, and all these things would be equal to each other. And that is your law of sines. Okay, and usually what they'll wind up doing is they'll give you, one or two of the values here, and they'll say use the law of sines to find either side B or angle B or something like that. Basically, they'll give you two or three numbers, and either you're going to use these two equations to figure out what the pieces are. You might have to use these two equations to find out what the pieces are, or you just may have to use those two pieces to figure out what the equations are. So it's just a matter of they'll say use the law of sines to find these values. You just plug them in, and then basically it's just going back to what we were doing before using your calculator to figure out what the missing value is going to be there. If we've got time, we'll come back and show you one of those, but we're kind of running a little bit short on time because it took a while to get through the unit circle thing. So we'll just kind of skip over that for now because we still need to show you law of cosines just to make sure we got everything in. So again, that'll be where they'll give you some missing piece here, and you either going to either set those two things equal and do cross products, set those two things equal, or set those two things equal. Okay, law of cosines. A little different one. It's got a different little version to it here. Okay, and same setup that we're talking about triangle ABC, where again, it's not necessarily a right angle. So we got side B, side A, and then side C. Okay, and we can derive the formula to kind of get there, but in this case, I'm just going to go ahead and give you this formula for these. Okay, so the first option you've got, again, this is always basically they're going to ask you to find side A or something like this. You're going to take sides B and C, square them. You're going to subtract 2 times BC, and then you're going to do that times the cosine of A. And the one thing that's always kind of the same, and we'll show you, there's actually 3 variations of this one. The one thing that's always the same on this part, whatever side you're going to find here, you're going to find the cosine of that same angle that's here. So the next kind of variation of the law of cosine says we're going to do b squared, but this time you're going to find the cosine of b. And just like these were the other two sides here, this one's going to be the other two sides here. So this is going to be a squared plus c squared, then minus 2ac. So it's one of those, if you can memorize one, they're all pretty much the same way. Okay, if you do c squared here, you're going to do the cosine of c here. And then in the middle, it's going to be the other two angles. So this will be b squared and c squared, and this will be 2bc. Oh, my bad. Yeah, AB. Oops. Thank you. AB. And that should be AB. Yeah, sorry about that. There we go. How about b squared plus a squared? There we go. Okay, now, and that one again, they will pretty much say use the law of cosines. And it's just a matter of which one of these 3 you need to use. And once you've got, pretty much it comes down to if they ask you to find side A, that you're using this formula, because again, you should be given BC in this angle for this part over here. So whatever 3 pieces they give to you, that's the one which formula you have to use. It should be this is the missing side that's always going to be your variable that's going to be there. Now they could kind of throw it around and they could give you angle B and have you find side C, but then you got to kind of get creative. You'd have to move this one over here, move that back around. So you might have to get a little creative with the angle that's there, but okay, we'll see. Again, we'll show you one of those here in a second. We still got a couple other little things we got to show you, and then we'll back up and see if we can pick up on that one. Okay, and then the last thing we've got to do, and this one's kind of the neat one of the bunch. Finding the area of a non-right triangle. Because it's a right triangle, it's really easy. It's length times width, you divide it by 2. No problem, easy to go, no problem at all. This is one where, again, if the side, instead of this being a right angle here, this thing kicks back a little bit so that we don't have a right angle anywhere. Okay, so they give you the pieces here. It's 1/2 BC sine 8. So if they give you these two side lengths and the angle that's included in it, so basically it's what you're looking at, is if they give you all dimensions in one particular corner, if we're talking about this corner here, we've got B, C, and A for this part of it. You can find the area just using that particular corner of what's here. Okay, and you can do the same thing in the other corner. If you're talking about everything that's in this corner for B that's here, if you drew in angle B, you'd be touching sides A and C, so then you can use A and C for that part. Okay, and if we talk about the sine of C, it's here, that's going to use A and B. So we can go there. So if you've got everything that's included in one corner, so if you've got angle C and side lengths A and B, you can actually figure out what that triangle is going to be based on the angles and everything that's there. Okay, so what we'll do is we'll go back and see if we can do maybe one example of each one of these just so you can kind of see some idea of what's happening with it here. Okay, so let's do this. Let's say we're going to find the area. Okay. If you're asked to find the area, it should be pretty straightforward because, again, it's not going to be a right triangle, but they're going to give you basically everything that you need. So it should be, we've got side length of 21, this angle is 48 degrees, and the side length is 12. Okay, so we're still going to use the 1/2. Go ahead and use your two side lengths that you've got here. But this time we're going to find the sine of the angle that's there. Okay, and from there it's just basically using your calculator. Oh, there we go. All right, so we've got, so we can get on the glare here. There we go. We got 1/2 times 21 times 12, so 0.5 times 21 times 12 times the sine of 48. There you go. It says it's about 93.6. Inches, feet. They didn't give us any units in this case. We'll just say technically that would be units squared. Okay, and the reason this kind of works, if you think about, we're still doing 1/2 of length times width in this case. Think back on your unit circle here. Let me just grab one that's right here. If we go to 90 degrees, what's the sine of 90 degrees? That's just 1, right? Because that's cosine and that's sine. So if we think about, if we were doing this like with the right triangle, you can still basically do the same thing with the right triangle. It's still 1/2 your length times width. But if you do sine of 90, that's just 1. So that's why you kind of get to throw that one out. So it's almost like y'all been taught a shortcut your whole entire life. That technically, this is the correct formula. But we've always done a shortcut because sine of 90 is 1. So you kind of get to take a shortcut there. All those years you were taking a shortcut and you didn't know it. All right, so let's use law of sines. So let's go with that being 32 degrees. Let's throw out some big numbers here. Let's say that's 1,200 and let's say that's 1,000. So like we'll never use millimeters. Let's go with some millimeters. Okay, we're going to find out what x is. Okay, and again, law of sines is the one that it should be pretty straightforward for this thing. That if they ask you to find these and ask you to use law of sines, then basically it's whatever angle you've got here, and you draw through that one, and it's basically going to be sine of 32 over 1,000. And if we're talking about angle x in this case, then if we draw through it, that's going to point to the 1,200 that's there. So it's going to be sine of x over 1,200. Okay, and then basically from there, it's just cross products. It's sine of 32 times 1,200 equals sine of x times 1,000. Now, if you do this, when you do sine of 32 times 1,200, it's probably better to put the 1,200 first, less chances of messing things up there. So you've got 1,200 times sine of 32. So that's 635.903. And that leaves 1,000 times sine x. Okay, so if we're going to get the sine by itself, we need to then go back and divide this thing by 1,000. So then we go back and divide that by 1,000. Okay, that gets us 0.6359. Okay, and again, you've got to figure out what the sine of this angle is going to be. So we got to figure out sine of what angle is equal to this part. That's where if you're going to get those numbers, you're going to have to use your second button, and it's glare that we can see it. So we hit your second, and then hit your sine button. So you got the sine inverse of, and then 0.6359. Okay, so that angle should be like 39 point. Again, they'll tell you at this point to round this thing off to the whole number or 1 decimal place. Let's round this thing off to 1 decimal place. Now, again, if it was AP, if anybody's taking AP chemistry or AP stats or AP, you're not taking AP calculus because you're here. If you're taking any other AP courses, you always go 3 decimal places and then you just cut the thing off. So on an AP course of any kind, it's just 39.486. And technically, yeah. So you just use all your decimal places that you have, and at the end, you can just cut it off to 3 decimal places. For now, we're just going to go ahead and round this thing off. Because you're going to hit second, hit sign. So X is going to say we're about 39.5 degrees. Do what? So for that one we hit second, and then we hit the sign button to get that one from here. So back here we had, when we did our cross products, we had 1,000 times sine x equal those two numbers. We divided by 1,000 to get the sine by itself, and because it's sine of x, we got to figure out what the angle is. That's where we hit second, and then sine, and then hit their number there. So that's what we had to hit on the calculator to get that answer to get there. Okay, so one for the law of cosines. Here we go. So let's do this. Somebody say something like this. In triangle ABC, A equals 17, B equals 4, C equals 19. Find the measure of angle A. Okay, so we've got to figure out what, so basically angle A is missing. So if we go back to our law of sines part we had back here, we got to find the one that's got angle A in it. So basically it's this one. Because that's the part we're trying to find angle A, so that's the one we're going to have to use in this case. We're going to use A squared equals B squared plus C squared minus 2BC times cosine A. So if we take all those numbers and plug them back in, we've got 7, let's just write down first. A squared equals B squared plus C squared minus 2BC cosine A. So that's 17 squared equals 4 squared plus 19 squared plus 2 times 4 times 19 cosine A. Okay, and then you can go ahead and get this with the calculator. 17 squared is 289. 4 squared, we've got that 16. 19 squared is 381. Put those two together, that should be 377 when we add those two together. We got minus 2 times 4 times 19. That's 8 times 19 is 56. It's 152. Cosine A. Okay, we're going to subtract the 377, take it over here. Leaves negative 88 equals negative 152 cosine of A. Slide that a little bit better so y'all can see that. Okay, and again, we're trying to get cosine A by itself, so then we're going to take this and divide by negative 152. Okay, so that leaves us with, and 2 negatives will make that a positive, so it's 88 over 152 cosine A. Now, some people will tell you to go ahead and put this in simplest form because you could actually, I think you can divide both of these by 8 and get this simplified down. You can do that. But if we're just going to find out what cosine A is, it really doesn't matter that it's in simplest form for that part, because now we're just trying to figure out that cosine A equals 88 over 52. That's where, again, we're just going to take our calculator now. We're just going to do second cosine of 88 divided by 152. And that, again, if we go off to about one decimal place, which I think is probably what they're going to ask you in homework, we're going to say that's about 54.6. Okay, so law of sines, a little bit more straightforward. Law of cosines takes you a little bit to kind of work through that one to figure out exactly what it's going to be and what it's going to go with it. Okay. And for today, that's about all the time we've got for everything that's popping in.